Welcome back to the Fullerton College Print 75 and 77 Pre-Press Combined Lecture. This is the video 3 of 3 of the PIA Pre-Press Trainee Manual Handbook, Section 1.3 Digital File Basics. We're catching back in here at document files. Document files are the files created by software programs. These are what I also know mostly as native files. They're the files that are actually created by the programs. If you're in InDesign, you have the INDD. If you're an Illustrator, you have the AIs, and Photoshops, you have the PSDs. If you're in Quark Express, I feel bad for you, and it's a QXP. So these files are the files that are actually opened normally in these programs. Double clicking on them will actually launch the software that made it if it's not already open. Native files are not the best things to use at all times, and sometimes, depending on the native file, they can be an issue for you. Before we jump ahead to image files there. This is why I had you watch the semi-related American Tail video here today, not just because I happen to really like that song, but also because that's something I want you to think about. The movie about a child lost by himself in a new world, searching for his family, who has such a hard time making it go by himself because he needs his family. That's how we want to think about our InDesign files and our Quark Express files, and sometimes our AI files. The native files from these programs are like unaccompanied children. An InDesign file without the supporting files, without the linked photos, without the images, without the fonts, without any other LinkedIn bits and other attachments that you normally use, is kind of useless on its own. It's an unaccompanied child. You should, if you ever see an InDesign file being sent to you from a client by itself, that should be like if you're in a grocery store and you see a little 3-year-old kid just strolling the stroller by himself. You're like, well, where are your parents? And if you see that InDesign file by yourself, you should be saying, well, where are your links? Where are your fonts? Somebody must take care of you. Without those extra files, they don't really work that well at all. So that's the downside of the document file. Although it gives you your native ability to go into a program and actually edit, you need the supporting files. Also, if you can get anywhere near Fievel and his sister's octave, my goodness, that's such a high voice. Okay, moving on. Image files, bitmaps and pixels. There are different ways of talking about them, but image files are typically your raster type files. They're pixel based. They are made out of those squares. We're going to talk about that again in a second. So there's a bunch of different ways of doing these. Bitmaps are made out of pixels. A bitmap is the old Windows version of the newer of the Macintosh TIFF, which is a pretty straightforward pixel grid of this color is this color is this for each little square. You guys know about pixels at this point. So any single pixel is one single dot on the computer, and it is given a certain amount of data and a certain amount of memory assigned to it, depending on which amount of memory you've given and the depth level of the color assigned. It can have one of 2 colors, one of 8 colors, one of 256 colors, or one of thousands, one of millions, or one of billions of colors, depending on how many bits of information is allowed to be given to each individual pixel. As you might imagine, the file size gets to be pretty big on these if you start giving it very complex color information. 2-color pixel files, which are just black and white, off and on, take very little memory for the computer to remember per pixel. But if you start getting into complex millions of colors RGB, you're talking about 256 levels possible of each of the 3 channels, which puts you into the millions of colors. And that also means you're applying quite a bit of memory to each square. And each little square, there should be thousands, nay, hundreds of thousands of these squares to make a good printable file. So you start to get a pretty large file by doing this. Pixel images, as we've talked about, they are resolution dependent. The size of it is depending on how many dots per inch do you want, because they're measured in pixels, not measured in inches or centimeters if you want to be metric about it. The question of how big is the picture is not really how big, but how big can you make it at what resolution? Because you have to divide by the pixels per inch to get the number of inches. Remember that for good quality printing, the minimum, not the ideal, not the goal, not some sort of lofty, if only we could. No, the bare minimum to make it look good is 300 dots per inch. Really good pictures are 600 or 900 dots per inch, and that's like jewelry magazines that you spend a lot of money on, and or like National Geographic type stuff that is just So good. So if you make them bigger, you find yourself with less and less pixels. You find yourself with less and less pixels per inch. You have the same amount of pixels no matter how big or how small. Think of them, because you know I view the world in these kinds of situations and these kinds of filters. Think about it like Legos. Your box has so many Lego pieces. You can build however much Lego pieces you have into something. How good of a thing you can build and how big can you build, it depends on how sparse you are with your pieces when you put them together. Vector graphics, as we've also talked about, aren't really in existence. I'd say this to be more interesting and fun, really. A vector is not a picture. A vector is an instruction to the computer about how to draw a picture. A vector has dots, and it has, sorry, dots. I shouldn't say dots. Dots is pixels. Bad llama, bad teacher. Don't talk like that. Vector graphics have points and lines that connect the points. The lines can be straight, they can be angled, they can be curved. The lines connect the points, and that makes shapes. And the shape's going to have fill colors in them, or they can have gradients, or patterns, or textures. But the point is, they don't actually exist until you print them. They are simply the instructions. While you're stuck with the number of Legos you have trying to build a bigger thing in the raster side, in the vector side, think about it again the way I always like to think about it, other than the pizza diagram, which I'll hopefully drop for you guys soon to give to you in a graphic version. When you're talking about vector, you're telling a computer to produce a square. We'll say square for an example because it's an easy one. You can have the computer print a square. Sure, print me a 1-inch square. And with those instructions, it can make a square at the best of its abilities at 1 inch. Great, now make me a 10-inch square. And the computer can follow those instructions and make the square at 10 inches. You could say, make me a mile square. Then you have a big park somewhere near Irvine. There's a lot of setup for a bad joke, but the point is, with vector, you're just giving instructions of what shape to make and what dimensions to give it. The resolution gets applied later in output. So no matter what you do, it will always show up at the best of the ability of the output device. Hooray, vector. Did I mention I like vector? Vector can also be assigned for non-printing tasks. It can be used for die line use, for cutout shapes. It's really fun. So pixels and vectors, those are the two types of images you can come up against. Again, the pixel is made up of dots and squares that arrange into a mosaic type grid to make a picture. To a computer, a pixel image is not an image. It's just a spreadsheet full of numbers for it to call up those numbers in order and give those values of colors for each of the squares. To a computer, a vector is actually an image. It's a shape, and it has places to start, places to finish, and dimensions to give. Here we are, the last little bit, file extensions. This is the part that's like that spotting chart I talked about from the very beginning of the very first video. Let's look at it again. Here we are again on my aircraft recognition chart. This is what we're going to look at now, although it's all file name extensions. This is like looking at the aircraft charts, where you're looking at wing shape and engine arrangement to know what kind of plane you're seeing flying overhead, so you can be a total nerd and say, hey guys, that's a Spitfire. Because that's what I do. You could too. Anyways, this is what this chart is that we're going to be looking at here, but for digital files. Oh my gosh, here we go, the extensions. This is the part at the end of a file name. You have file name dot and then some letters. And those letters tell the computer what type of file it is and what programs to use to open it. You can also learn to look at these little suffixes, these extensions, and you can then identify what you're going to be dealing with when you look at them. .indd is an InDesign document. That means that Adobe InDesign is going to want to open it, and that also means, like we were talking about with Fivel and getting lost in New York and moving to America and all of that, you need to find its parents. You need to find its linked files, its fonts, all those other things that are necessary to make it work. Same goes for Quark Express files. They're very similar. They're similar programs. They have the similar problems. A Quark Express file by itself, unless it's a pure text file using only a very basic font, needs its supporting files. AI, pronounced I think. The Illustrator documents don't necessarily need anything else, and those will open in Adobe Illustrator. I like them a lot. .psd are the Photoshop files. That means it's a layered pixel image, which has different layers of transparencies that can be used as well within it. .jpeg, it stands for the Joint Photographic Experts Group, which is the group of international business and scientists who work, businessmen and scientists who work together to develop this particular type. If we were in person, I would name drop a little more, but all I have to say is your instructor does actually happen to personally know one of the people who was a part of the Joint Photographic Experts Group in the 80s who helped develop the JPEG because he worked for Canon. It's not that me or my family was smart. It's that we happened to live up the street from Caltech. So our neighbors that we met on walks as kids are really smart people. And sometimes that's enough. The TIFF, the tagged image file format, this was the Apple version of the general bitmap type file, and it was trying to be the greatest file, and it really is one of the best files you can get for a raster image. A TIFF does not compress anything the way a JPEG does. I should go back and mention that. JPEGs use compression algorithms to make the pictures fit in smaller memory. One of the reasons they are so prevalent nowadays is the same way you're doing your class right now, the internet. Because JPEGs were invented for quick and easy transfer across networks. They compress the file, and it's called lossy compression. They lose some of the information of the file to make it smaller. So when it appears on the other side, it doesn't have all the details it should have had. It more or less gives you an average of what you're kind of more or less looking at. I guess since it is October, I'll put another video up for you guys to watch since I can't really put it in here. But this would be your army of darkness, Ash trying to say the magic words to stop the Deadites from taking over. Klaatu Varakta Nik something. He doesn't remember all of it. He only gets most of it. And that causes some problems. Same goes for JPEG and its compression. It doesn't get every detail. It gets some of the details. We also have the BMP. The BMP and the TIFF are basically the same, but the BMP was the Windows version and the TIFF was the Apple version. Of course, when I hear BMP, I think of this, the old Russian armored transport tank, the BMP. Now, just for the heck of it, this is a BMP, but if I save this, the file save as here. Uh-oh, I think I stopped sharing. Oops, teacher fail. Saving the BMP, we can save this. Make sure we're still sharing the correct page here. Yep, we're good, okay. I can actually save this as a BMP. So, yo dog, I heard you like BMPs, so I saved your BMP as a BMP. Now you have a BMP of a BMP. You'll notice that the file format has a Windows version. You have different bits, 16, 24, 32-bit. That is telling you how much color information is available per pixel. Doesn't matter for me right now because I'm just going for the pun and the joke of how much Chuck could have woodchuck chuck and all that good stuff. We're back to the proper thing. PNG, portable networks graphic files, those are useful, but not for everything. Portable network graphic files are internet images meant to be sent across the network. They're kind of an improvement on the JPEG to make internet image sharing easier and make smaller images. And they support transparency, which is a good thing, but they do not support CMYK color space and cannot be tagged with ICC color profiles, which is not good. EPS, when I was a kid and getting into printing and learning this stuff growing up, and I was just starting into graphics, this was it. It was the bee's knees, see? The encapsulated PostScript was a way of saving, remember PostScript when we talked about from our PDF thing, PostScript is that secret language that computers use to talk to printers. So EPS was just saying, well, let's just save that and let that be the file type. We'll just work directly in printer language, which is good, but not great. The file size was too big, too slow, and too clunky. And for those of you who've gone through 101 in our classes on campus and have used the Rampage system, you'll know that EPS does not actually embed any of its images. So if you try to output, Alexa, stop. If you try to output an EPS onto a plate maker, you're going to have problems of needing to get the supporting files, just as if it was an InDesign native file. And lastly, we have the chosen one, the PDF. I've already gone a whole lecture or two on just why that particular file type is good. So let me say it's wonderful and I love it in all ways. And if you want to know more, go back and watch the PDF chapter again. That's it for today. Thanks and goodbye.